Great. All right, section 4.7, transformations of polynomial functions. What's great about this section is it's nothing new. Okay, this is the same stuff we've been doing, transformations in chapters 1, 2, and 3. Okay, now we're just applying it to polynomial functions, higher degree, x to the third, x to the fourth, fifth, so forth and so on. Okay, so our objective for this lesson is to be able to describe transformations of polynomial functions and write transformations of polynomial functions. Okay, so first let's go ahead and let's go over our rules. Okay, let's say if f of x is my parent function. Okay, to shift it vertically, again vertically up and down, to move it vertically up or down, okay, I take my function, okay, and I add or subtract onto the end. Okay, so I add k onto the end. Okay, if I add k onto the end, this is going to, again, here I take my parent function. Here's my parent function, f of x, and I add k onto the end. This would then move it up k units. Okay, if I take my function and subtract k from the end, again, there is my original parent function right there, then this is going to move it down k units. Okay, it's going to move it down so many units. So if this was a add 5, it would move it up 5. This was a subtract 3, it would move it down 3. Let's move every point down those 3 units. Okay, horizontal, left and right. Again, if you remember, horizontal works backwards on how you think it would, okay? And it works inside the function, okay? So I would take my f, and instead of putting an x in it, I would put an x minus, oh, sorry, let's get some color in there. X minus k. Okay, that's going to move it up k units. And if you notice, this applies it into the function. That's my whole parent function. It's f of x minus k. This guy right here goes inside the function. Okay, and f of x plus k, okay, is going to move it down. Oh, up. God, anybody catch my typo there? Gosh. Okay, that's going to move it to the right. K units, subtract k, and then adding k inside is going to move it to the left. Gosh, we're moving horizontally here, guys. K units. Hopefully you caught that. Okay, so my subtract k in there is going to move it to the right, k units. Okay, my plus k in there is going to move it to the left, k units. So describe the transformation of, here's my original function, f of x equals x to the third. So there's my parent function, x to the third. Okay, so represented by, here's my new function, g of x equals, so I have x plus 5, so here's my x plus 5 to the third plus 2. So this plus 2 is on the outside, so that's going to move it up 2. This plus 5 is on the inside, so that tells me it's going to move it to the left 5. So it says describe the transformation of, so what g of x is going to do is it's going to move the f of x function left 5 and down, up 2. It says then graph each function. So what I'm going to do is I'm just going to create an f of x function, okay, for this. So when I put in a 0, 0 to the third is 0, so you have the point 0, 0. When I put in a 1, 1 to the third is 1, 1, 1. When you put in a 2, 2 to the third is 8. So 2, 1, 2, 3, 4, 5, 6, 7, 8. It's going to put away the heck up there. When I put in a negative 1 to the third is negative 1. When I put in a negative 2 to the third is negative 8. 2, 1, 2, 3. Okay, so it's kind of going to do a bit of this curvy thing like this, and it's going to go. Okay, so there's my function. There's my f of x. Okay, my original function. Now what we want to do with this, guys, we want to move it left 5. So left 1, 2, 3, 4, 5, up 2. So there's my 0, 0 point. Okay, move this point over left 1, 2, 3, 4, 5, up 2. Move this point left 1, 2, 3, 4, 5, up 2. So basically it's going to be the same curly thing, just left 5, up 2. So I was able to get that graph without even having to use my graphing calculator at all. Okay, you could. Okay, and that's what you'll end up getting. Okay. All right, next, reflections. Okay, if you don't remember your reflections, okay, depending on how you flip, you can reflect over the x-axis, which, again, your x-axis is right here. So it's going to take whatever's up here and it's going to flip it down, or whatever's down here and flip it up over the x-axis. Okay. If you reflect over the y-axis, here's my y-axis here, it's going to take whatever over here, flip it over on this side, whatever's over here, flip it on that side. Okay, so it's going to flip from one side to the other for y-axis. Again, my parent function, if my parent function's f of x, for an x-axis reflection, okay, for an x-axis reflection, the negative doesn't go on the x. The negative goes out front. So we have negative, I always think of it as negative times the f of x. So I make this whole function negative. Okay, it goes outside. This is outside, out front of the whole function. Outside of the entire function. Okay. Whereas if I want a y-axis, I actually put the negative on the x. So it would be f of negative x. So I put this inside on every x. So if it's a negative inside the function, if I want to flip it over the y-axis, okay, left to right, I need to put that negative inside on every x. Okay, and that's kind of like here my horizontal, if I want to subtract, if I want to move it to the right k units, I need to subtract k inside from every x. Okay, same here, this plus k needs to be added to x on every x. Okay, so we'll do a couple examples on what that looks like here in a minute. Okay. All right, so now our stretches are vertical and our horizontal. Again, vertical, like up here, our vertical's nice. Our vertical's easy. You just add it on the end. Okay, same with our stretches and shrinks. Okay, what a vertical stretch and shrink is going to do is it's going to take all your points and it's going to stretch it up and down. So it's going to pull all of these points up and it's going to pull all of these points down. Okay, vertically, up and down by the same value, so many times bigger. Okay, and it's going to put it on the outside. So I would end up having like a k times my function f of x. Okay, and if k is greater than 1, it'll be a stretch. And if k is in between 0 and 1, it will be a shrink. Okay, if k is negative, then it's going to be a reflection. Okay, so k here is only positive for stretches. If it's negative, it's a reflection. Okay, whereas a horizontal again works backwards. Again, horizontal always works backwards, but what a horizontal stretch or shrink is going to do is it's going to stretch or shrink out horizontally, left and right. Okay, or it'll push it in by that same amount. Okay, and what that does is that actually puts the k inside the function f of k times x. Again, I multiply by that k by every single x, so it's inside on every x. But again, this one works backwards. Okay, if k is greater than 1, it's going to shrink it by 1 over k, the reciprocal. We'll just put recip. Okay. If k is in between 0 and 1, okay, it's going to be a stretch. Again, it's going to stretch it by 1 over k. Whereas here, it's going to stretch, here with my vertical, it stretches how you think of it. It's going to stretch it by k. by 5. If it's 5, it's going to stretch it 5 times farther. Okay, and it's going to shrink it by k. It's not reciprocal there. It's not backwards like the horizontal is. Okay, so again, nothing new here. This is all review from previous stuff. Okay, here, describe the transformation of f represented by g, then graph each function. Okay, so first thing, here's our parent function. Here's our parent function. It's taking x and taking it to the 4th. So now we want to look here and we want to break up. I've got a negative out, but if you notice here, there's my x to the 4th guy right there. Okay, that negative's out front. So that negative out front is going to be a reflection in the x-axis. So that negative out front is going to be an x-axis reflection. Okay, and this 1/4 out here is again out in front of the x to the 4th. So that 1/4 is going to be a vertical stretch or shrink. But since it's less than 1, it's going to be a vertical shrink by 1/4. Basically, it's going to shrink everything and make it a 1/4 of the distance away from my axis there. Okay, so if I create an xy chart, an f of x chart for x to the 4th, 0 would be 0, 1 to the 4th is 1, 2 to the 4th is 16. So, I don't know, maybe we want to count by 2's here. We'll go, this would be 2, 2. So 1 would be 1. 2 would be 2, 4, 6, 8, 10, 12, 16. Way the heck up here. Okay. But then negative 1 is also 1. Negative 2 is positive 16. So we're going to kind of have this kind of guy going on, parabola-y looking guy. Okay. But if we want to put a negative out front, that's going to be reflected in the x-axis. Well, here's the x-axis. So it's going to flip all my points down. Okay. But then it's going to shrink it vertically. It's going to shrink it this way. So it's going to be 1/4 as far. So what that means is my final is I'll still have the point 0, 0, because if I flip over. But now in this one, if I go over one here, I want to be 1/4 as far. So I'm going to be really, really close here. I cut that into 4 equal pieces. So same with this one here. But now for 2, we'd have 2 16, but I want to make this 1/4 as far. So I want to take the 16, a 1/4 of 16 is 4. So instead I have the point 2, 4, which would be here. So it's going to squeeze it down. You see here, it's going to take all our points and it's going to squish them down by a 1/4 because it's switching vertically. Okay. All right, so now on this next one here, okay, so here's my parent function right here. X equals x to the 5th. This 2, if you notice, where's this 2 located? It's in on the x. They took this x and replaced it with a 2x. So they multiplied the x by 2 inside, which means that's that guy's inside, which is going to be horizontal, and it's going to work backwards. So since it's a 2, it's going to be a horizontal shrink by, instead of 2, 1/2. So it's going to take all of them and squeeze them in half their distance this way. Okay, it's going to squeeze them in half their distance that way. Okay. All right, so here we graph x to the 5th. I'm just going to go ahead and I'm going to graph this guy in my calculator, because it's always good practice doing that. We're going to have the point 0, 0. It's kind of going to be this steep little curvy thing. Okay, so we'll have the point 0, 0, point 1, and then negative 1, negative 1. Because if we look, we can trace it. 0, 0, 1, 1, negative 1. But 2 goes all the way up to 32. So this guy's going to be super steep. Okay, oops, sorry, bumped. So it's going to be super steep like that. Okay, all right, but now I want to horizontal shrink. I want to make the things half as far this way, left and right. So this point, I want to make it half as far away from that axis. So it's going to go here instead. This one's going to go here instead. Since 0, 0 is right on the axis, 0, 0 is going to stay where it's at. So now it's going to be even steeper. because it's shrinking it in. Think all those points, shrinking them in half as way. Do you see the difference between horizontal shrink is going to shrink them in this way. A vertical shrink is going to shrink them in this way. Okay, so we have that difference there. Okay, so there's my 2. All right, so here example 3. Let f of x equal, so here's my parent function right there. Let's go ahead and let's highlight that guy. Write a rule for g and then graph each function. Describe the graph of g as a transformation of the graph of f. So g of x is going to equal f of negative x. So my negative there is inside of the function. I have that negative because it's f of negative x. It's inside there on that x. So since it's inside, it looks like that. So that's going to be a y-axis reflection. So I know we're going to do a y-axis reflection, so we really took care of that, describe the graph of g. It's going to be, so basically g of x is a y-axis reflection of f of x. So now what I want to do is I want to take f, and I want to, instead of putting an x in here, I'm going to put a negative x in there. So my g of x is going to equal, so instead of x here, I'm going to have negative x to the third plus negative x squared plus 1. Okay, so I replaced all my x's with negative x's. So negative x to the third, well that's negative x times negative x times negative x. Negative, negative, negative gives me negative x times x times x is x to the third. So I'll have a negative x to the third plus negative x to the second, that's negative x times negative x. Negative times negative is positive. X times x is x to the second, and then a plus 1. So there's my g of x equals this guy right there. Okay, and then now dot, 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 I want you to go ahead and graph those two functions. Okay, it's a reflection in. So we can look at the graph of x to the third plus x to the second plus 1. Okay, so let's go ahead. Here's the parent. Okay, let's trace. Let's get some points. Trace, we have the point 0, 1, 1, 3, negative 1, 1. Let's go negative 1.5. See what's happening in the middle there. 0, 1. Let's just go negative 0.5. I want to see what's happening in between these two. I don't think it levels out. Is 1.25. Negative a half is 1.25, so it's a little up. Okay, so it's kind of... Yeah, kind of goes up there. Goes up and comes back down. Negative 2 is negative 3. Okay, so it's kind of doing a thing like this. Okay. And then now we want to reflect this in the y-axis. So if we reflect this in the y-axis, this axis right here, this axis coming straight down, so we want to flip the points over. So this point's going to be in the same spot. Here, let's use a different color. This point's going to be in the same spot. This one's now going to be over here. This one's going to be now over here. This one's going to be here. This one. So then we'd have this guy right there. Okay. So there's my reflection over that y-axis. Okay. All right, next one here. Okay, g of x equals 3 times f of x. So I want 3 times my f of x. Well, since I'm multiplying a 3 out front, this is multiplying that 3 out front. That would be a vertical. It's that k out front here. So it'd be a vertical. Since it's bigger than 1, it'd be a stretch. So this would be a vertical stretch by 3. Since it's vertical, we don't need to worry about flipping it. So for my g of x, I want to take 3 times this whole function, times that whole thing. So if I want to multiply this whole thing times 3, I need to do that. Put parentheses around it. So I'm going to take 3 times everything. So that's going to distribute that 3 in. So I'd have 3x to the third plus 3x squared plus 3. Okay, so we know what the parent function looks like because we still have that same parent. Okay, so our same parent has the point 0, 1. Okay.
Connie Clout, line 1, please. Connie
Okay.
Clout, line 1.
Sorry for the interruption. So we still have the same parent, but now we want to stretch it vertically. We want to stretch it up and down by a factor of 3, which means we want to make these points 3 times as far. So since this is 1, we want to take 1 times 3, which is going to make it 3. So instead of point 0, 1, we'll have the point 0, 3. Since this is the point 3, that's going to make it 3, 9. It's 3 times 3 is 9, so that's going to make it way up here at 9. 1, 2, 3, 4, 5, 6, 7, 8. Way the heck up here. Okay, since that's going to be negative 9, this 1 is also going to be 3. So basically, it's really stretching it up and down. It's taking all these points and pulling it 3 times as far that direction. Okay. All right, last example, and then we're done. Okay. Let the graph of G be a vertical stretch by a factor of 2, followed by a translation 3 units up of the graph of, so here's my parent. So here's my parent right here. Right there. Okay, so there's my f of x. So we're going to do one thing at a time. So first let's do a vertical stretch by a factor of 2. To do a vertical stretch by a factor of 2, my new function, vertical stretch, is multiplying out front by a 2. So to do this vertical stretch, a vert stretch by 2, I want to multiply 2 out front times my f of x. Well, this is my f of x right there. So I'm going to take 2 times that whole thing, x to the 4th minus 2x squared, which ends up giving me 2x to the 4th minus 4x squared. So this is my new function that we're working with now. So this is my new parent. So now we're going to deal with that guy. Okay, so that was after a vertical stretch by a factor of 2. All right, next, followed by translation 3 units up. So to translate 3 units up, okay, so now we're going to translate up 3. I want to take this function and add 3 onto the end, right? If we translate, we want to move up 3. Up 3, we put a plus k on the end. So I would take this function here. This is my new f of x right here. So I'm going to take 2x to the 4th minus 4x squared, and we're going to add 3 onto the end. Simplify if you need to. Hey, but I don't see any simplification there. There's nothing I can add, so there's my new function. My new g of x is 2x to the 4th minus 4x squared plus 3. Again, one thing at a time. Color coding helps. Highlighting helps, so writing the problem out might be helpful. But again, only do one step at a time. Do one thing, simplify it. Then do the next thing, simplify it. Okay, don't do too much at once. You will get confused. Okay, all right, so write your practice problems down here on the bottom, and good luck.